All right, let's jump right into an explainer that is going to completely shatter how we think about modern game development. Look, if you grew up playing those classic Naughty Dog titles, you already know the magic of a great 3D action runner, right? The vibrant colors, the crazy fast pacing, the incredibly precise jumping. But today, we're looking at something genuinely revolutionary. We are talking about how to build a complete 3D browser game, heavily inspired by that classic Crash Bandicoot style, all in just about an hour. And we're doing it using Three.js and AI subagents. Yeah, you heard that right. 1 single hour. What used to take entire teams of developers weeks or even months to stand up, it's now literally happening over a lunch break.
I mean, it sounds almost impossible, doesn't it? But that's exactly the core question we're tackling today. Can you actually build a complete, highly polished 3D browser game in just a few hours? We're going to deconstruct how a wild project called Claude Bandicoot Schumer's Gauntlet Loop manages to pull off AAA-style mechanics right there in your web browser. And honestly, the absolute most mind-blowing part of this whole experiment, it does it without a single heavy asset. No massive multi-gigabyte downloads, you don't have to sit there staring at a progress bar just waiting to play. No heavy textures, no massive MP3 files. The whole thing is built with pure code, which means it loads instantly and plays perfectly. Think of this agenda as our level select screen. We're going to conquer the single file engine, procedural characters, and web audio. Then we'll uncover the secret AI weapon making this possible, and finally look at the zero build revolution. Let's get into it. Okay, level 1, the single file game engine. We've got to talk about the sheer technical audacity of packing an entire game engine into one place. Because the contrast between traditional game development and this new approach, it's literally night and day. Traditionally, to build a 3D game, you need separate teams. Artists crafting heavy 3D sculptures, your massive .gltf models, alongside huge audio libraries. And then you have to stitch all of that together using insanely complex node software and massive asset pipelines. It is a heavy, slow, grinding process. But this approach? It completely throws all of that out the window. Zero external assets. The entire game uses a single, lightweight HTML text file that just pulls in a web language called Three.js. Instead of spending weeks configuring servers and waiting for gigabytes of visual assets to compile, you get an instant, fully playable deployment. Boom, done. Moving right along to level 2, procedural characters and worlds. Because, well, if we don't have heavy 3D mesh files, how exactly are we building our hero? Okay, since we have no pre-made 3D models imported from an art program, our character is generated entirely by code. It's kind of like a digital Lego set, right? Pure procedural math acting as our digital clay. The engine is essentially stacking virtual math formulas instantly, on the fly, to sculpt him out. His torso and head, just generated using scaled cylinder and sphere geometries, instantly painted with custom orange fur and a tan belly. The facial features are built from pointed cones for ears and an extended snout. The limbs are fully articulated with white gloves, jeans, and red shoes, all attached to pivot groups for skeletal animation. So the character you're interacting with is literally just math rendering itself in real time. So without pre-rendered animation frames from a human artist, how does he actually move so naturally? Well, the code levels up the animation using real-time trigonometry. Instead of drawing a character running frame by frame, the procedural animation engine uses math, specifically sine waves. Think about a sine wave, right? It smoothly goes up and down. That mathematical wave is the perfect substitute for a human animator. It creates a completely natural swinging arm for a run cycle or a perfectly smooth velocity arc when he jumps through the air. And those classic action platformer moves? Simple rotation transforms execute a perfectly smooth 360-degree spin attack, while compressing the math of the character's mesh gives us a slick, totally satisfying sliding mechanic. But building the hero is just half the battle. We also have to build a breathing world. To make this endless jungle gauntlet feel alive, without loading massive memory-heavy level maps, the engine uses this brilliant infinite scrolling illusion. Basically, it's a digital treadmill. The character is completely stationary in the center of your screen, while the track segments and the world actually rush backward past him. And to make it look stunning, the code calculates real-time PCF soft shadows, meaning the shadows are realistic, slightly blurry, and react perfectly to the flickering point lights of the jungle torches. Throw in some exponential depth fog to cleverly hide the track segment spawning in the distance, plus physics particle bursts for every wooden crate you smash, and you've got this gorgeous environment generated entirely from numbers. All right, level 3, web audio and game mechanics. Because let's be real, a video game isn't a game without sound and a challenge. Now, this part is wild.
The underlying code basically acts as sheet music for the browser, and that is absolutely crucial because it completely kills latency. There are no MP3s or WAV files to load, so absolutely nothing lags. Every single sound effect is synthesized on the fly using the browser's native web audio API. When you actually look at the math, it's amazing how it translates to your ears. A frequency-modulated sine wave sweeping from 150 to 450 hertz, that is literally just the math equivalent of a classic cartoon slide whistle going bloop as you jump. Collecting fruit is a dual-tone triangle wave melody, a crate shatter is just a burst of bandpass filtered white noise, and the explosions are crafted from low-frequency sawtooth decays. The browser is literally playing an instrument made of code.
And all this snappy, synthesized audio perfectly complements the fast-paced gameplay. The game uses a 3-lane system where the player smoothly interpolates, which is honestly just a fancy technical term for gliding, between the left, center, and right lanes to navigate hazards. You're constantly dodging explosive TNT and green nitro crates, smashing boxes, collecting fruit, grabbing shields. Now, traditionally, coding all these complex hitboxes, collision detections, and speed increments would take a developer days of frustrating manual tweaking. But here, the elegant math logic just progressively scales up the difficulty, continuously increasing the track speed with each distance milestone flawlessly.
Welcome to Level 4. This is the boss battle. We're finally revealing the secret weapon that built all of this in just hours instead of weeks. So how in the world do you code complex Three.js geometry, trig-based animation, and synthesizer math so fast? The answer is a framework called the Schumer Gauntlet Loop. This is the core magic trick of this entire project. Instead of one single AI struggling to write an entire complex game top to bottom, you have a highly coordinated team of specialized AI pair programmers. These subagents focus intensely on individual domains of the game engine. And the most fascinating part is what's called the critic layer. Imagine an AI art director standing right over the shoulders of these junior AI developers, instantly reviewing their math, testing their logic, and fixing bugs before a human ever even has to look at the screen. It is an incredibly powerful workflow. And the Schumer Gauntlet Loop divides the labor perfectly across these subagents. This massive parallelization is exactly how you break that 1-hour constraint. You've got one hyper-specialized sub-agent spending its entire processing power just painting the digital character. At the exact same time, another agent is composing the math-based soundtrack. Another is building the physics engine. Another is handling the UI. Because all of these complex systems are being built simultaneously by specialized agents talking to each other, a complete, robust 3D engine can be conceptualized, coded, debugged, and spun up in roughly 60 minutes. Finally, we've reached level 5, the zero-build revolution. Let's talk about what this incredible workflow actually means for the future of web development. We just need to pause and appreciate the sheer technical achievement here. Despite generating all of these 3D assets programmatically, rendering exponential fog, calculating real-time shadows, and synthesizing audio entirely within a standard web browser without a single pre-rendered asset or loading screen, this single-file game maintains a buttery, smooth 60 frames per second. No stuttering, no lagging. It is a massive testament to the raw efficiency of pure procedural generation running directly in the browser. So, what does this zero-build revolution actually mean for you as a developer, a creator, or even just a gamer? Well, it means that complex, gatekeeping build tools are becoming completely optional. Zero-build deployment means you can host a game instantly via GitHub pages just by dropping in one simple HTML file. Procedural geometry means your massive load times drop to literal milliseconds. And crucially, it democratizes game creation. AI-assisted pair programming, utilizing these specialized subagents, takes what used to be weeks of frustrating setup and coding and turns it into just a few hours of pure, unadulterated creative output. We are literally standing at the edge of a completely new era for coding enthusiasts, indie developers, and gamers alike. You can now generate highly efficient, production-ready experiences with just a single idea, a little bit of Three.js knowledge, and an AI workflow. So looking at how incredibly fast this technology is moving, if AI can help you build a complete 3D jungle gauntlet in a few hours today, what universe are you going to build tomorrow? Seriously, grab these zero-build tools, fire up some subagents, and see what you can create over your next lunch break. Thanks for joining me on this explainer, and keep building.